In question 43 in chapter 11 of our physics textbook, it talks about a nuclear plant typically generates 2,000 megajoules of thermal energy during a reaction. It says the energy is used to boil water and produce high pressure steam at 300 degrees Celsius. And it says that steam spins a turbine which produces 700 megajoules of energy, and the steam is then condensed into water and is cooled to 30 degrees Celsius before starting the cycle again. And so this question has two parts to it. Part A, which is asking what is the maximum possible efficiency of the plant, and part B, which is what is the plant's actual efficiency. So to start with part A, what we need to do is put our information that we have. They give us the output, which is 700 megajoules, and the input, which is 2,000 megajoules. And then it also tells us that it gives us two temperatures. Temperature 1 will be the 300 degrees Celsius that it gave us, and temperature 2 will be the 30 degrees Celsius that it gave us. And since it's in Celsius, we need to convert it to Kelvin, because Kelvin's usually how we cancel out units. So to convert it to Kelvin, we just added 273.15 Kelvin to it, which will get it into our Kelvin units that we need. So we take 300 plus 273.15, we get 573.15 Kelvin. And then we do the same for the 30 degrees Celsius, which that plus 273.15 give us 303.15 Kelvin. Once we have those converted into Kelvin, we can then use our first formula, which will be for part A, which will give us the maximum possible efficiency of the plant. And so our max efficiency, the equation we're going to use is our max efficiency equals 1 minus T2 over T1. And so if we enter in the values that we have into this equation, we should get 1 minus 303.15 Kelvin divided by 573.15 Kelvin, which equals 0.47. And then if we convert that to a percentage, all we have to do is times it by 100, which would give us 47% as our efficiency. And so then next part B asks, what is the plant's actual efficiency? So in order to do that, we can actually just use the values that it gave us at the beginning, and we can find that our actual efficiency equals to the output divided by the input. And so if we input the information we have, our output was 700 megajoules, our input was 2,000 megajoules. So we basically need to do 700 megajoules divided by 2,000 megajoules, which the units cancel out, and we get 700 divided by 2,000, which equals 0.35. And again, if we want to get that to a percentage, all we have to do is times it by 100, which will give us 35%. And so the answer to part A on what is the maximum possible efficiency of the plant is 47%, and then our actual efficiency of the plant is 35%. So we can see from both these answers that the plant isn't as efficient as it could be. The maximum efficiency it could be at is 47%, but it's actually only 35% efficient, which is pretty typical of most things. Usually they're not as efficient as like the max potential could be, but that's how you do question 43 in chapter 11 of our physics textbook.